Hello, everyone. This is the Space Cafe podcast, and I'm Marcus. Have you ever wondered who holds the crystal ball to the future of the space industry? Let's just forget, for the sake of this episode, about the usual suspects for a moment. Instead, let's picture someone who has got some serious skin in the game, whose livelihood even depends on getting those cosmic forecasts right. That's right, we're talking today about investors, the unsung prophets of the space age. And maybe I have a little bit of a treat for you today, because today we're sitting down with no other than Christian Ziach, a man who has worn a bunch of hats in the space industry, from engineering the groundbreaking MASCOT mission, where we sort of played interplanetary darts with an asteroid, to now calling the shots at a high-tech founders fund. Christian's got a front row seat to the Space Cafe and to the space, not only the Space Cafe podcast, but to the industry's blockbuster show. And today we're trying to pick his brain about everything, like the current state of the European space endeavor. And all I can say already is I think it's not going to be smooth sailing in this respect. To the mind-bending possibilities of asteroid mining. And just wait until you hear Christian's thoughts about our potential Martian future, which is not all red dust and potatoes, folks. So why don't you strap in and get ready for a journey that's part rocket science and part fortune telling, and all fascinating. We might not be able to defy gravity today, but I promise your mind will be floating by the end of this episode. Let's go. Have fun.
Yeah.
So what's going on in the European space sector when it comes? There's been a bunch of attempts to also go into the launcher business and whatnot. So what's the current state of affairs? Where is Europe headed? And how do we compare to the rest of the world? I know it's a big question.
Yeah, it is. I mean, starting with the launcher industry, I mean, we have all witnessed what happened in the US with the several launch attempts of Starship. So I think SpaceX is leading the pack.
It's hard to beat.
Yeah, they're showing us the way, in other words. And according to Josef Aschbacher, Europe is back. Yeah. But the question is, are we back with the right vehicle? Yeah, at the right point in time, at the right, price. And I would put a big question mark next to it. Yeah. We see several small sat launch providers in the making. I mean, they have announced their launch attempts for later this year. We have witnessed what can go wrong. I think a few days ago, there was this dramatic stage test in Scotland. It was a test conducted by colleagues from Rocket Factory Augsburg. And I wouldn't overestimate the outcome of such a test. I mean, it's what I would call work in progress, so it's perfectly fine. And I think we will see that more often. And I think that is needed in order to fail forward. Yeah? And that is exactly what SpaceX was doing over the last years. Not every attempt of a new launch vehicle was successful, but they basically said, okay, we will fail. But while we are failing, we learn a lot, yeah, and all the failures are priced in, and while doing that, we will make big progress, yeah,
absolutely,
and we will come, around with a new class of vehicle. We will have a two-stage, fully reusable launch vehicle at the end of this process, and we have to understand in Germany, in Europe, yeah. this is the way to go. This is the right mantra. Yeah, we should not be afraid of failing. Yeah, of explosions on the launch pad. Yeah, this is something we will see more often in the next months to come. And in my understanding, that's part of the business. And all the investors backing these companies, yeah, I mean, I hope they are aware of these risks and they are aware of the chances, and they have financed their companies accordingly. Because if we take SpaceX as the best-in-class company in that sense, yeah, it took them with Falcon 1 4 attempts to reach orbit, yeah. And we should give our startups also a similar chance, yeah, to succeed, yeah.
We celebrated, you mentioned Josef Aschbacher, we celebrated the first launch of Ariane 6 quite a bit. Ariane 6 is not reusable.
Yes.
What do you make of that?
Well, what shall I say? It's a decision which was taken a long time ago. It was a decision when it was clear that SpaceX is on a different path, that they are all in when it comes to reusability. And in Europe, I think the general school of thought was like, okay, if we go straight to a reusable vehicle, that might be too much for us, yeah, for the risk appetite of the decision makers, which are working with taxpayers' money, yeah, and I think they missed a chance to leapfrog, yeah, a generation, a generation of launch vehicle here, yeah, and Ariane 6. I mean, it will fill a market gap, yeah, which exists, yeah, and it's booked, yeah. So the order booked is nicely filled, no doubt about that. But when it comes down to the numbers, yeah, in terms of pricing, we have to ask ourselves whether this vehicle is competitive in the long run, and I have still some strong doubts about that.
Is Ariane booked because of subsidies, or is Ariane booked because it's a great vehicle and it's in great need?
I think it's because it's a vehicle and it's hopefully available at the right point in time. I mean, what nobody wants is, monopoly, yeah, on the launcher side, yeah. And we should not be naive about SpaceX business practices here. I mean, they will lower the cost only further if they face more competition. Yeah. So all the other launch providers, whether they're small or big, they need to assure that they deliver on their plans, and that will, lower the prices. Yeah. And that will help us to open space for future businesses, which are currently maybe out of reach due to the launch cost.
Do you have any intel as to where the European launcher sector is headed? Because I could imagine that once Ariane 6 is now becoming a workhorse, or is already the workhorse it was designed and built for. So I guess the next generation is already being worked on and developed. So is that next generation something completely different?
I think what will change and where we see a lot of discussion is the way, ESA is or will procure the next launcher. So the procurement strategy will change. Especially German decision makers asked for more competition, with demanding more competition. And I think that is important. And it should not be like, okay, only companies with a certain traction, heritage should be eligible to participate in such a competition. We should also give, newbies a fair chance to compete. Why so? I mean, we've all witnessed what happened with Boeing, with United Launch Alliance. Yeah. So they followed the traditional path. They are used to work with plus contracts, and we see the outcome. Now we have probably 2 stranded astronauts on board of the ISS,
Yeah.
And if that's, the claim here, to trust, established company, and I would say thank you. Maybe that's not longer the right way to do business. Maybe other companies, and we see, how SpaceX is doing this, are in a better position, in a better shape to deliver, on time, on cost and quality.
Whereas, because we've been talking so much, not only us on the show, because it's still very early, but the media is full of SpaceX, and of course, Elon knows very well how to play that musical instrument, that organ, so to say. But what's happening at Blue Origin at the moment? Where are they at?
That's a very good question. I mean, there are some rumors out there that they are interested in buying United Launch Alliance. If you might know that Blue Origin is a supplier to United Launch Alliance. They provide the rocket engine to the Vulcan rocket. And they would be interested, to step into this business in order to be eligible, for the large governmental launch contracts which are in place. And as of today, the only 2 eligible companies are SpaceX and United Launch Alliance. And, they were suing each other, in the past. And Jeff Bezos was really trying hard to get, a foot into the door of this multi-billion business. And, acquisition, which I would assume could easily afford, would contribute to this larger plan.
I'd like to come back to that in a minute, but I'd also like to come to your core business, and you have your roots in engineering and your roots in DLR in the space industry, but then at some point you moved into the investment business in the space industry, and I'd like to take the liberty to use also your expertise to look a bit into the future. And you, as the principal at High Tech Founders Fund, you are very much aware of where to place your bets and where to place your money. So, wherever investors are placing their bets is a good indicator as to where something could be headed. So let me ask you this: which areas or types of projects in the space industry are receiving the most focus, the most funds from your end, from the Founders Fund?
Yeah, I mean, I would always say walk the talk, right? So where you put the money in, you're probably on the right way here. And I mean, you can. You see, and you are probably aware of all my previous investments in this space sector, And currently, we are very much interested in the field of dual use, resiliency, everything what makes a significant contribution to the resiliency of our space systems. So I think it's really interesting to look into alternative GPS solutions. If we see our, assets in a jammed environment, for instance, it can affect not only, military assets, it can affect planes, ships, which are then guided, by jammed signals. And that is, I think, a very big business and interesting investment opportunity. Next to it, given all the risks we see in space from the growing number of space debris, and given the fact that some actors in space do not behave as responsible as they should, it's, I think, important to make our assets in space also more resilient. And what do I mean by that? I mean, they should have, the capability to maneuver without regret. That is also something what was asked for by the United States Space Force. They would love to assure that their assets, which were also sometimes called juicy targets for certain reasons, they would love to maneuver them without sacrificing the lifetime, because you need to fuel, for all the station keeping maneuvers, etc., to assure that they are in the right position. And if you have to move your satellite because another satellite is chasing you, is spying on you, or you're under attack, or you have to avoid collision with space debris, it goes all at the expense of your lifetime, and that is something what limits your capability in space. And militaries, especially in the US, don't like to be limited in the usage of their assets. And they would like to see means of refueling, to give them a wider envelope, for their operations and for their maneuvers. And that is something which is still, in an early phase. I mean, there are not too many companies out there. Was, for instance, Orbit Fab in the US. They are already working with the US Space Force. There are not too many players in that field in Europe or in the rest of the world. I think that is a very important topic, even though we still don't know, how all the economics will pay off. This is still very early market, and time will tell how things will pan out at the end of the day. Next to it,
can I just ask a quick question regarding refueling, just out of curiosity? So this is a new technology applied to old technology. So is old technology, are old satellites even equipped to be refueled, or aren't they bolted tight and shut because they were never intended to be refueled?
From a design point of view, the vast majority is not equipped to be refueled, but there are means, to live and to work with the existing design in terms of conducting refueling missions. Sometimes you have to open a valve, you have to remove certain thermal insulation layers, etc. So it requires also robotic, systems to do this basically maneuver and to do the entire refueling. So it's not like you can fly to a gas station or a satellite with a fuel tank will come to you and will do a refuel in a few minutes. It's not. It won't be like that. It will be more difficult in the early phase, but in the future, and that is something, for instance, Orbit Fab is working on. Satellites will be equipped with the ports, with fueling ports. And the question is, will these ports be standardized? Will these ports be proprietary? Or will we follow a kind of open strategy, so with an open standard? Because imagine you would have a car, and you would go to a gas station, and your fueling port is not compatible with what the gas station is providing or operating. And this is something we need to assure. And I would say the vast majority of the customers is probably interested in an open standard solution, because nobody is interested to depend only on one supplier, on one monopolist in that field. You want to have a choice as the customer. You want to have the freedom to fly to gas station A, B, C in space in the future. If you take the decision to go for a refueling strategy. But of course, refueling is probably only something, especially in the beginning, for very expensive satellites in geostationary orbit. As of today, I would have some doubts that it makes economically sense to do in-orbit refueling, for instance, in low orbit. So in a low orbit, the assets need to be replenished more often. You need to have more satellites to do to fulfill your coverage needs. For communication applications, for Earth observation, and you need too many satellites. So for that reason, it makes more sense to replenish your satellites after a few years rather than conducting expensive refueling missions where you have to fly to each and every satellite. The effort, I think, would not justify the cost or the benefit would not justify the cost in the very beginning.
Is satellite technology, of course, we're talking about a variety of different satellite uses, but are the costs generally coming down? Or because it seems like the constellations that Elon Musk is putting up into orbit on a daily basis in the dozens and hundreds and thousands, they're just throwaway pieces, throwaway hardware. It seems like they're very cheap. So is that technology in general coming down? Because you're mentioning it doesn't really make sense to refuel. So where do we stand here?
That's a very good question, which cannot be that easily answered. Because what we see currently in the market is that, for a very long time, we have seen that the size of the satellites was going down. That was basically the advent of small satellites, so to speak. But over the last years, we have witnessed that even though satellite builders have the chance to take advantage of miniaturization, etc., and of the usage of commercial off-the-shelf components, etc., they have reached basically the limits what you can achieve in terms of usability with small satellites. We have sent small satellites to the moon, to Mars, to deep space, but if you have more ambitious missions for Earth observation, communications, you have certain limitations, and these limitations are set by physics. And you have to go then for larger satellites, and that's what we see. So satellites are bigger, so where you can save costs. Okay, still you can use a commercial off-the-shelf, but a main, lever here is mass production, automatization in the production, and what you are asking is basically one very difficult question for all the constellation operators out there. Are they, in a position to close their business case in the long run? Because at the end of the day, you have to ask yourself, okay, you have to finance the design and development phase, the production phase. You have to finance launch. Then you are operating this constellation for several years, and you have to make your profit down the road. So, and the question is the outcome still financially attractive enough to convince future investors to finance, the second generation of satellites? Question mark. And interestingly enough, Elon Musk tweeted a few years ago, I don't know which kind of mood he was, he had some doubts concerning, the viability of the business case of Starlink. And I asked myself, was this a kind of attempt to shy off, other constellation operators in the communication business and their investors? Because if he has doubts to close the business case on Starlink, and he's in the best position to do that, his its own launch capacity, he has the know-how and the industrial means to mass produce satellites at little cost, and if he has still doubts to close a business case, what shall the other competitors do or say about this? And I don't know whether it was a maneuver again to shy off the others, or whether these doubts were justified. there were certain sources which claimed, okay, that last year was, the first year when Starlink was profitable. That is something what we cannot, verify because, as you know, SpaceX is a private company, so they are not obliged to publish any numbers. Yes, so it's a black box in essence, but one can only, estimate, what's going on in the company, and one can only estimate how expensive it is to launch these satellites, But from what we know from, for instance, other constellation operators such as OneWeb, they had a hard time, to arrive at the required unit costs for their first satellite generation. And in my understanding, that was among the reasons why we went through Chapter 11 at some point in their company history.
I'm just wondering from my layperson's perspective, I'm just wondering where all this is headed, where all this ends, because even the limitless space of outer space is limited. So we just seem to be getting the hang of constellation production and satellite production and getting cargo and freight into orbit. So we seem to be getting comfortable with bringing matter into orbit, but orbit is limited. So where is all this headed? Because we already spoke about space debris. We have no viable solution how to clean up dead hardware floating out there. So the question is, are we headed toward disaster? Because there is a natural limit to all of this that we're doing. No matter how fantastic the business model behind it is. So from your perspective, how do you react to this as an investor?
I think we haven't reached the limits yet. But as you said rightly, we're on a not sustainable path. But if we think of all the decisions and actions taken by satellite operators, if they fail to find a way to use their orbits, in a sustainable manner, they will dig their own grave here. And that's something they cannot afford. So it's in their own interest, to assure that they behave in a responsible manner. In the same time, since space became the ultimate high ground also for various military applications, and that we are from a geopolitical point of view not in the best position to find agreements, binding agreements between the leading space nations to behave more reasonable. We can only hope that all the individual actors will act in the best interest of a sustainable usage of space. Otherwise, it end up in a situation that certain orbits will be, not usable any longer for a very long time until we decide to afford, a massive cleaner up mission or something like that. But the question would be who should be accountable for this and who should finance it. If you think of all the debris removal companies out there, the question is who will be the customer of them in the future, right? So they have always, a strong dual-use exposure, in my understanding.
It's like on Earth, who is responsible for the trash we're leaving on our roadsides? Who is responsible for the cans and waste? People
exactly.
It's the same problem. It's the human problem.
Exactly. It's our human nature. And we all complain if we find a plastic bag, on the beach, but financing ocean cleanup mission is also something what we haven't done yet.
Christian, I cut you short with too many questions. So were these the major projects that you that you're focusing on with your investments?
I would add a few things. So you mentioned already the congestion in space, and we see a growing number of satellites. And in the past, it was like, okay, ground operators were in charge of all the operations in space. That is something we cannot longer do, because the number of satellites have outgrown, the means of, manual control, etc. So we see growing interest in, autonomy and capabilities which allow satellites to be operated in an autonomous manner. The rise of AI will contribute to that. And in the same time, we need to think of solutions to enhance the onboard processing power. And since this is also a strong consumer of electrical power, we need also to think of, okay, how can we provide more power to our satellites? As you know, power on board of satellites is produced by solar panels, And the question is always, okay, how can we ensure that even small satellites have enough power to fulfill their energy consumptive missions? And D-Cube, for instance, one of my portfolio companies, came around with a solution to print structures for solar panels to afford even small satellites to fulfill their power-hungry missions.
So it means the surface of the small satellite, I don't know if it's a CubeSat, but the surface itself is a solar panel.
Typically, if you take a small satellite, a CubeSat, the surface area is limited to the size of the satellite. So, and not all the surface areas are pointing towards the sun. So it limits your power production means dramatically. But if you have a solar panel, and if you can stow it during launch, which is by far larger than the surface area of your main satellite body, you can produce more power compared to what you could produce with just the surface area of your main satellite body. And there are different means. I mean, you have to find means to attach such a panel to a small satellite body, And D-Cube came around with new ideas, like origami structured panels, which can be stowed in a small volume, and which allow small satellites to fulfill even energy demanding missions.
Could that also feed back to technologies needed on Earth? So I guess there could be a dual use, and sometimes or very often investments in niche applications can scale and spill into different worlds also. So maybe this kind of solar efficiency approach can have some scaling application on Earth also, which would be beneficial to your portfolio, I guess, as an investor.
Honestly, if I think, of unit economics here down on Earth, I don't see it, But what you're outlining here is, the right way to go for many companies. If you are interested to do something in deep space, or there were even companies aiming to produce solar cells on the moon. I think Mana Electric from Luxembourg was one company with a plan to do that. Yeah. Their initial approach was like, okay, producing solar cells on the moon is a tall order. Yeah. Before we do that, that's our long-term vision. We try to do that in the desert here on Earth. Yeah. We say, okay, the efficiency of these solar cells is not as high as the solar cells which are, produced in a clean environment with everything perfectly calibrated, but we can mass produce them for a fraction of the classical approaches or cost. Yeah, and that is a way to reduce the risk for your mission. Yeah. And to generate revenues, down the road, while you're still aiming for the ultimate mission to do something, on the surface of the moon. And there were also other companies. I forgot the name. One company which was in the robotic segment. Offworld was the name. Offworld was about to build robotic systems for mining applications. First here on Earth, because the working conditions for workers, if you have a diamond mine or so, 1,000 meters under the surface of Earth, it's the conditions are really harsh. The temperature is really high, and if you can demonstrate that you can do basically the same job with a robotic system, you can already retire many risks which you see in space later on, for instance, on the surface of the moon. Even though you have to realize you have vacuum, you have radiation, you have a different thermal environment, but still it's a system which has either to work on its own, by means of autonomy, or remotely controlled.
Fantastic. Christian, where do you get your portfolio candidates from? I mean, like you have to be on the road, I mean, like all the time to scout for interesting projects, or where do you get those new concepts from? How do you find them?
Yeah, we have close ties to all the leading research institutes, like Fraunhofer in German Aerospace Center, DLR here in Germany, Max Planck Institute. But we also have good relationships with all the leading universities here in Germany, but also due to alumni in across Europe. And it's really important to visit all the relevant conferences. And our aim is to be, the first institutional investor. So as soon as a group of founders take a decision to set up a company, we would like to sit next to them. That is what we're aiming for. In order to assure that they find the right partner from the very beginning to get their company financed. So yes, we we spend many days on the road on an annual basis, but in the same time we have to take care of our own portfolio. And word of mouth is also supporting our mission. If we do a good job with our founders, they introduce us to new founders, and that is also an advantage.
I'm just wondering, I don't know if it's different in Germany, but in Austria, research institutes, scientists do not always have really an understanding that what they do is market worthy, because of course most of the time they're in fundamental research, and they're not like really interested in doing anything else than what they're being paid for and what their passion is, and that is research. So and this is a huge gap, to have an understanding that what you do is valuable in a different place in the world. So how do you get them to understand that?
Yeah, it's a very difficult topic, so to speak. Why so? first and foremost, we need more university or research institute spin-offs. All right. So, I mean, if we have a high rank in the patent ranking on a global level, it's good for our ego, but it won't help our economy, so to speak. So what we need to do is we need to have more technology transfers. We need to assure that all the patents which have been filed are commercialized. And the question is how to do that. I mean, there are many research institutes out there, and they already understand that and this need. And the question is, if you have these discussions with researchers, the question which arises very quickly, are these also good founders? Are they just, interested, to check the box because, the organization they're working for is asking for it, or is motivating them, to assure that, to a certain level, they commercialize their research, because our major point of concern is when it comes to researchers turning into entrepreneurs, do they have, the right motivation, the right skills, and most importantly, something what we call a product market fit mindset. Because in many cases, also here in Germany, researchers think, okay, or engineers, my technology is so great, it's superior compared to what's already on the market, and we don't need to do any, market research or interaction with customers. As soon as the customer will see what we have developed here over the last years, they will come in and they will order our technology and our product in large numbers. That's unfortunately not the reality. And in order to overcome this status quo, we need to educate, researchers, future founders, that it's different. Some of them have already the right mindset, so there's no need to educate them. But if you think of, the curriculum of the universities, entrepreneurship was not always, part of the academic education. Luckily, things have changed now. Many technical universities offer such courses, and this is the right way to do it. And we love to partner with universities. And we give lectures on this topic to assure that they have a good start and that they have a fair chance to get a financing round closed, etc. Because without these people, without these founders, we're nothing. I mean, this is our resource, so to speak. And we need to assure that they will get, the best education and training which is possible.
But one could say, should the scientist also be, as you mentioned, the good founder, the good entrepreneur? Maybe we're asking too much of some, and we're taking them away from what they're really good at great research. So it's like the artist who is a very rarely a good businessman or a businesswoman. So the question is, can we think of something different? Can we come in with something else, maybe a completely different team, to leave the scientists to what they do best?
Yes and no. So if we see, okay, that there's a solo founder, or that, a small founders team is not the right skills from our point of view, we can help them. We can help them to extend the management team with our network. But it's not that easy, because the chemistry needs to be right.
Of course.
They have to accept each other. Exactly. And the researchers will always say, okay, but we have spent, so many years on this. We are the ones with the know-how here. So why should we accept external boss, so to speak? Yeah. On the other hand, if you want to finance such a company, I mean, there are also company builders out there. Yeah. They install a completely external management team, but at the end of the day, from our point of view, the most successful, founding teams are those where, the original founder is the one with the know-how and is really burning for his idea, as we say in Germany, who is, the driving force behind it, and not just, kind of arbitrary team, which is being paid to do this mission, so it would lack the right soul or spirit, so to speak, if it would be, a paid management team. So that is at least our observation here. Yeah. And we need to give, the founders also with a strong academic background a fair chance to grow into their new role. And we have good examples in our portfolio that can work out.
Completely different topic. You had a different life before being or becoming an investor. And that different life was also connected with a fantastic mission together with DLR, if I'm not mistaken, the MASCOT mission. It was all about landing on an asteroid. It's so we're in the same process as we speak again now with multiple asteroid encountering missions, the Hera mission, the DART mission, in the future, the Apophis mission, or Ramses, I think it's called. So can you speak a little bit about that mission back in the day, the MASCOT mission, what it was about and why it was important? Yeah, sure. Please take it away.
Yeah. I mean, as you might know, I started my career with the German Air Force, and while I was still an officer with the Air Force, I was following the Hayabusa Mission 1 very closely. And as you might recall, the Hayabusa 1 team was facing many difficulties with their subsystems. So they barely managed to return to Earth with some asteroid samples. So it was a huge success. And later on, they quickly decided to set up a follow-on mission, Hayabusa 2. And they basically figured out, okay, what were, the difficulties faced during the first mission, and they addressed all of them. And in the same time, they invited, international partners to make a significant contribution. And DLR was bold enough to make a contribution. And I don't know whether this is really true, but from what I know, they asked first JPL to contribute a lander. But the development time was, according to my knowledge, too short for the colleagues from JPL. So they said no to this opportunity. And instead, a team formed by colleagues from DLR and CNES got this flight opportunity.
That's crazy. And, if JPL can pull it off, who else can?
Yeah, exactly. And this the mission lead or the system lead was done by a newly formed institute, the Institute of Space Systems in Bremen. And it was the MASCOT mission was among the first flight missions of this institute. So luckily, our team was formed by former colleagues from the Rosetta Philae mission. Especially, they helped us, on the payload side. And it was really mix of very experienced colleagues, In the same time, there were many newbies on board, And I was the system engineer for this mission. And it was a tall order. But for me, it was, once in a lifetime opportunity if you leave armed forces and get the chance to become a system engineer for such a mission. That was a very big opportunity. And I was not sure whether we will succeed. because we had only 18 months from the beginning of phase C until delivery date to the launch pad. But we succeeded, and once everything was launched, in 2014, there were not too many things we could do. We could, work on follow-on missions. We could send up new software versions. Think of what to do once we would arrive at the asteroid, because basically, if you fly to an asteroid, you don't have too many information about your target. We were dealing with high level of uncertainties with regard to what is the rotational axis? What is the day-night ratio? So it's basically like you plan to go for a camping vacation, but you don't know whether you will end up in the Arctic or in the tropics, or in the desert, in terms of how should your thermal system be designed? You have to deal with different, potential thermal regimes, and you need to assure that the system which you launch, several years before you have this knowledge, works in different or under different conditions. And that was a big challenge for us, but it worked. In 2018, on 3rd of October, the landing occurred, and it was a picture-scenic mission. And would you have asked me before whether it will work out like that?
I never.
I would have some doubts, but yeah.
So you wouldn't have placed your bets on that mission?
Probably not.
I cannot recall the actual mission, but I remember there was a landing attempt on an asteroid somewhere, and it turned out, because we know so little about asteroids and the asteroid surfaces, that it turns out that what seemed to be a rock-solid surface was very squishy and even like a liquid, and so the lander threatened to sink, to go under on that surface. Can you recall what that mission was?
I know what you're talking about. It's about it's like if you think of an asteroid like cloud of small rocks, and basically
so it's not solid.
It's not solid. It can happen that what appears to be an asteroid is basically rock formation, formed of small rocks. And the only way to learn how it's built is to fly to it and to learn more about it. And what I learned from this mission is if you know one asteroid, you know only one asteroid.
Yes.
You have the spread and the diversity is really high, and we need to conduct more missions, probably more efficient, maybe with the help of startups, to learn more about them, because as you know, asteroids are potential threat for us, but in the same time, they might be a potential resource for future space missions with rare metals, for instance, and with ice deposits, which can be maybe utilized for ISRO missions. So I think it's paramount to learn more about them.
Speaking of which, when are we starting? Because we've been talking quite a bit about asteroid mining on Earth now, so it's a part of science fiction, and then we get to hear it now and then. But when are we actually really starting to do it? Is there research going on? Are there any mining projects on the horizon?
Yes.
Are you placing your bets on asteroid rare earth mining?
Well, coming from this space branch, I'm kind of skeptical. I mean, there were already heavily financed startups 10 years ago active in that field, namely Planetary Resources and Deep Space Industries. They are basically out of business, and you have to deal with different challenges. Of course, you have to lower cost for launch, for in-space transportation, etc. But the most difficult challenge which needs to be addressed is how do you interact with the asteroid itself? So how could you potentially extract, the materials, the resources you're interested in? I mean, if you're talking about volatiles, you might find means to heat up the asteroid with solar power, for instance, and you find a way to collect the volatiles with cold trap, for instance. This is a concept company in the US is working on. They call their spacecraft the Space Bee. I have no insights as of today about their funding status or about the development status. But I think it was a day or 2 days ago that Astroforge announced another financing round. And Astroforge, for instance, is working, on another asteroid mining mission. So they follow also a stepwise approach. First, it's always important to get more information about the target asteroid, to learn more about the properties, and you have to get an understanding, okay, what could be a potential means to extract the rare metals, but you have to understand we're talking about an environment where you have basically, depending on the size of the asteroid, no gravity. So as soon as you try to do some mechanical action, you will realize
counteraction.
Counteraction, exactly. And Isaac Newton will say hello to you. You find yourself again in higher orbit, so around this asteroid. So that is the main difficulty. I mean, if we depict, space mining, there are some pictures, in the web where you see trucks or mining machines, which we know, from coal mines here on Earth, placed on the moon. On the moon, you have relevant gravity. That's not the case on the vast majority of asteroids. So, and my understanding, if you're interested not to digest the entire asteroid, to extract a few tons of the materials you're interested in, you need to come up with a totally different chemical processes. I don't know, maybe nanobots or things like that. So technology which we currently don't have in our disposal. So if you ask me, finally, okay, are we years away? I would say we are decades away.
Really?
Yeah.
Interesting.
Yeah.
But it's potentially a huge so it's a huge bet, because it could be. So I mean, like, just imagine just investing 100 billion or 1 trillion in research and technology, but getting 100 trillion back. Because I can't remember the celestial body, but a couple of weeks ago, I read somewhere that they discovered a celestial body in our solar system that has an 11-mile strong diamond layer. So, I mean, like, you got all the diamond supply you will ever need on that celestial body. So, all jokes aside, there's a huge opportunity, but getting there is maybe the challenge. It's pretty much similar to what is happening now in the AI sector. Huge investments necessary in order to get somewhere.
Yeah, that's absolutely true, and you should not ignore, the market reaction towards such an increase on the supply side. Yeah,
exactly.
So the colleagues from the Colorado School of Mines, they did some research on that. Yeah, you cannot count on price stability as soon as you have tapped into such a vast resource. Yeah.
So that means if you mine a golden moon, you are at the same time destroying gold price.
Yeah, you have then to feed the market very carefully.
Over
For the
millennia.
price. It's like during the oil crisis in the 70s. You have then to control how much oil is entering the market, and you're then the in power of the price control mechanism, so to speak. Yeah.
Speaking now, branching out a little bit into the future also, because you said you need to place your strategies very carefully. Where do you see the space industry headed? What's the omega point that we're headed toward? I keep saying on the show almost on every single episode that perhaps we're starting to become an interplanetary species. We're starting to leave planet Earth, perhaps because we're discovering the technological necessities, and we're getting ever more used to leaving Earth. And because we can do it, as Elon Musk pretty much demonstrates it with the Falcon rockets, and perhaps in the future with Starship. But what's your take? Because you're pretty much, to me, you're a crystal ball, so to say, because you're very knowledgeable and very well informed when it comes to anything that goes together with the space industry. So
yeah, I mean,
where are we headed?
That's the driving question is who's sitting in the driver's seat, right? I mean, if I think back of the situation in the late 90s, we were stuck in low Earth orbit. The ISS was delayed for different reasons, yeah. And only with the advent of new space and new space companies, we have seen relevant progress, yeah. So that gave me hope, yeah. Honestly, when I was, 20 years old, something like that. And I think ultimately we're heading towards that direction. I mean, that is also Elon Musk's goal, lifetime goal, so to speak. But we should not count on space agencies, in my understanding. Yeah, and if you find a way to show that you can make money while you're heading towards Mars, you're in the best position to fulfill this vision, or to turn this vision into reality. Yeah, and currently, or as of today, all the customers who are paying, for all the services, name them, communication, Earth observation, PNT solutions, they're here on Earth. So the question is, when will we see, a tipping point that we will make more business with the space industry in space rather than here on Earth? And we haven't reached this tipping point yet. What might be a contributor is, is what we call the great power competition between the US and China. So they are in a kind of second space race. The moon, or cislunar, is considered to be the ultimate high ground. That means if you have the possibility, for instance, to extract lunar ice deposits and to produce fuel, which allow you then to refuel your satellites in cislunar and geostationary orbit, which make you maybe independent from supplies from Earth, because all the orbits in between are crowded, you're in a superior position. And I think if you want to build it in a very economic manner, a lunar station, for instance, which does this job, you have to rely on commercial partners. And that is something what colleagues from the US are aiming for, in my understanding. They don't want to do and build everything by themselves. They want industry to come up with these capabilities. Yeah, and of course they appear as an anchor customer. But everything what will be created next to it, kind of adjacent industry, will contribute to this very first step beyond low Earth orbit or geostationary orbit. Yeah, and from them we need to see. I mean, how far or how long it will take us as humanity to make the next step to Mars. Yeah.
Would you want to go if someone asked you?
Of course, I'm ready to go. If somebody pays the ticket or invites me, I would definitely go. Yeah.
I was pretty quick because your reply. Because I could imagine that there's initial excitement, but at some point, when you're realizing that you're confined to a very small area on Mars and that Mars, in fact, wants to kill you, the question is, how exciting can it still be?
Absolutely. And I think if we discuss, the future of humanity on another planet, I think we have touched so far only the tip of the iceberg. Yeah, it's not just about surviving. It's about, staying there and reproducing. Yeah. And think about it, what will make with an embryo, with a baby, if it grow up in a different gravitational environment. So I think we haven't done enough research on that yet. Yeah. To discuss all the consequences. Would we be required to fly back to Earth to reproduce? Because if we reproduce on another planet, on Mars, here, I mean, the baby, I don't know whether it would be survival, or it would survive, from the bones, etc., on Earth.
That's very, very tricky. We had two representatives of Spaceborne here on the show, a Dutch company doing research in exactly that field. And from what I heard so far and what we discussed, it's extremely tricky on multiple levels. First of all, you cannot really test this kind of, or you can't do research because you're doing research with human sperm and human eggs turning into something weird, maybe, usually something weird. So it's ethically not viable to do it. And from animal testing, what they say is the odds that some ill-formed consequence comes out of this is still very, very high. So conception is a huge issue. Birth may be an issue. So it seems like we're not meant to procreate somewhere else. Of course, this is a non-scientific approach towards this problem, because maybe no one means us to do anything at all in the first place.
Yeah.
But it seems very tricky.
Yeah. But in the same time, if we accept, our genetic code as it is, what you're describing is true, yeah. But there are also some voices out there, yeah. You say, okay, before we start, to work on spacesuits, yeah, we should maybe start to think of working on our genome, yeah. And that's a big ethic question. Yeah, maybe we need to adapt in a different way to this new environment. Yeah,
it's really interesting.
But, that is then a totally different discussion. Yeah, and it's difficult to predict at which point in time we will have such a discussion.
It's really interesting because currently, someone pointed me a couple of weeks ago. Someone pointed me to Andy Weir, the author of The Martian. And so I read Project Hail Mary, which was fantastic. And currently I'm reading Artemis. And Artemis is all about, I don't know, have you read any
No.
I can highly recommend. It's hard science fiction, so it's science fiction you can actually draw science from, and really, you as an engineer, it could be really interesting. But while I'm mentioning that, on the Artemis, in the Artemis story, there is this woman who was born on the moon, so she never developed a skeleton that would be viable on Earth. So she would never ever go back to Earth because she wouldn't be able to live a normal life on Earth. So this is maybe already the first step towards becoming something else, becoming a different. We would be the same species technically, but we would have found a different niche to evolve into, maybe.
Yeah, it would be a new branch. And the first time I encountering this topic was in the early 2000s. I think, have you read First Landing, written by Robert Zubrin?
Mm-hmm.
It was about a first human mission to Mars, and female astronaut, pregnant, and basically they decided to stay on Mars, because abortion was not an option for her, and she and the astronaut father, stayed together on Mars, and formed basically the nucleus of a new civilization.
Wow.
Highly recommendable book.
And then you got your Adam and Eve story starting all over again.
In essence, yeah.
Christian, you mentioned you would go to Mars without giving it too much of a thought because you feel like that would be your thing. Going to Mars takes about a couple of months, I think, with current space craft technology. So, I assume that it could be getting slightly boring at some point to just get there. So my question to you, what's the one piece of music you would want to see on a playlist to accompany you on that journey and to cheer you up? The reason I'm asking is because I'm asking that question every guest on the show because we have a Spotify playlist. It's the playlist for the aspiring space traveler. And each guest gets to contribute one of their favorite tunes to that playlist. What's yours?
Billy Idol, We Can't Stop the Fire.
Fantastic. And one last question. This place here is the Space Cafe podcast, and it's a coffee place, so to say. And now and then you go into coffee places to energize yourself by having an espresso. Now I'm challenging you to share an espresso for the mind with me, with the audiences. What could be an energizing espresso for the mind you would like to share, and whatever kind of topic you want to pick?
I think given what we discussed so far, we should ask all of us, okay, what is our desired future in space? Yeah, and who should be in charge of, shaping this future in space? Shall we leave it to politicians, to space agencies, to billionaires, to investors, to founders, should we ask the general public, to vote on a topic, should it be a random thing, because we don't care whether we make progress or not, and this is something what is not clear to me yet, and that would be my espresso for you and for the audience.
Fantastic. Christian, thank you so much. This was really inspiring.
Thank you for having me, and have a nice evening.
Thank you. And that's a wrap, my friends, on today's cosmic journey with Christian Ziach. What a ride it's been. At least for me, it's mind-blowing to hear the investors' perspective of things from those guys who are literally invested in something, and who should know what's going on in the world so as to not lose whatever they're investing. If you liked the show, and if you like what we're doing here on this little planet called Space Cafe Podcast, why don't you share and subscribe? You're already subscribed, but why don't you share our little planet with someone you feel like could be interested in what we're doing here? And for your personal needs, why don't you consider adding Billy Idol's "We Can't Stop the Fire" to your personal playlist, like the one we have on Spotify, the Aspiring Astronauts playlist, for your personal future journey to the stars or the next space race. You make the choice. You call the shots. Until next time, my friends, keep looking up, stay curious, and remember, in the vast expanse of space, the only limit is our imagination. This is Marcus signing off for today from the Space Cafe Podcast at Astra, my friends. Thanks for sticking around. Bye-bye.